So I want you to try and calculate the apparent weight. What force is apparent weight? Normal force. So we're looking for normal force here of a 75 kilogram person as they travel over the top. Gentlemen, over the top, that's on the outside of a vertical circle. Okay, we want to find out what their apparent weight is if the circle's 150 meters in radius and the speed is 22 meters per second. So in this question, listening please, in this question, we're going over the top of a vertical circle. Okay, so we're in this situation here, meaning gravity is pulling into the circle and our apparent weight or normal force is acting out of the circle. Okay, so because it's a vertical circle, we've got forces in minus forces out. Okay, and we're looking for, in this case, the force out. So we have, if we're looking for the force out, so we'll just say Fc equals the force of gravity minus the normal force, right? I don't like to solve for stuff if it's negative in an equation, so I'm going to bring normal force over here, okay, by adding it. So I'll have Fc plus Fn equals Fg, and then I'm going to subtract Fc over to this side, okay? So I've got normal force equals Fg minus Fc. All right, now, I got to plug in my numbers here to figure out what Fn is. So that's going to mean Fn is m times g minus mv squared over r. Okay, and that's going to mean we have a 75 kilogram person, okay, times 9.81 minus 75 times, how fast are they moving? 22 meters per second, okay, divided by the radius of the circle, which was 150 meters. All right. So I got 75 times 9.81. Okay, and then I'm going to subtract from that 75 times 22 squared divided by 150. Okay. Whoop. Oh, that's a bit. Yeah, I forgot a zero here. Yeah, I forgot a zero on the 150. Yeah. Okay, so we got 735, sorry, 0.75 minus 75. Oh, man, I am having a whole bunch of trouble typing today. What the heck is going on here? Okay, so there we go. We got 4.9 times 10 to the 2 newtons. So, does that person feel heavier, lighter, or normal? Lighter. Yeah, they feel a little bit lighter than normal because normally they would feel this heavy. Okay, 735.75 newtons. So that would give you that sensation that we sometimes get when we go over the top of a vertical circle. Okay. All right. Questions on how that one worked? Okay. What's the matter, Tanner? Yeah, that's what we did. We subtracted two numbers. We subtracted gravity minus centripetal force. Okay. Want you to try this one. So this is about the vomit comet, that plane that we watched the other day, okay? The one that makes people feel like they're in zero gravity. Right? We want to find out how big of a circle it needs to fly in order to make people feel weightless if it can fly at 210 meters per second. That's the speed they cruise at when they're going over the top of that circle. Okay? So we need to know how big does the circle need to be. Yep. Okay, so here's what we know. Okay, we know that the speed of the vomit comet is 210 meters per second, and that's all they give us, and that's all they have to give us. All right, so it's a vertical circle, and they're flying over the top of it. Okay, so they're again at this position here. Okay, where we're going to have gravity pulling in and normal force acting out, except there's no normal force because they have apparent weightlessness. Okay, so really what we're saying is Fc equals Fg, and that's it. Right, so we have to go mv squared over r equals m times g, and we're solving for r. So I'm going to multiply both sides by r and then divide both sides by mg. The m's will cancel, okay, and I'll be left with v equals the square root of, or sorry, r equals v squared over g. Okay, that's it. That's all I have to do that one. Okay, we take our 210 squared and we divide it by 9.81, and we'll have the radius of the circle. All right, so the radius of the circle is about 4.5 kilometers, okay, which is about right for a plane traveling that fast trying to go over the top of a vertical circle. Passenger planes do not normally make tight turns. Okay, if they do, okay, then things can go wrong. All right. Okay, want you guys to try some of the vertical circular motion problems that are in the digital workbook here now. So, all right, so we are looking at pages 2 and 3. Okay, that's where the questions are, is pages 2 and 3. Let's get going on those, and then I'll help you out if there's any we need to go over. Okay, so listen carefully here for number 3. All right, so the student has a weight of 65 or 655 newtons. So that's the force of gravity, because that's what weight is, 655 newtons. While riding a roller coaster, the same student has an apparent weight of 1,950 newtons at the bottom of a dip, okay, that has a radius of 18 meters. So we know what R is, and we know what their apparent weight or normal force is. It's 1,950 newtons. Okay, so in this situation, the forces are gravity acting out of the circle, normal force or apparent weight acting into the circle. Okay, we want to find the speed of the roller coaster. All right, so that's going to mean then that Fc will equal normal force minus the force of gravity. Forces in minus forces out. Okay, if I'm trying to manipulate to solve for V, that'll look like this. Okay, this number we already know. Okay, there's no formula for that because we know that number. Okay, minus m times g. So I don't have m. Can I find it? Sure I can, because I know what their weight is. Okay, if I know what their weight is, I can find their mass simply by going 655 divided by 9.81. It's a number I'm going to need for the question. Okay, so we'll just calculate what it is real quick. Okay, so 66.77 kilograms. Okay, now we can manipulate and solve for V. All right, so I'm going to bring R over to this side. So I'm just going to bracket this and then multiply by R. Right, and then I'm going to divide both sides by M, and then I'm going to square root. Okay, so I'm going to have V equals the square root of 1,950 minus mg, which is just 655, okay, divided by, or sorry, multiplied by r, which we said was 18 meters, and then we're going to divide that by our 66.77 kilograms. Okay, so we have the square root of 1,950 minus 655 times 18 divided by 60, actually by our answer. That way we get all the decimals in there. All right, so we're looking at, it's got to be moving at 18.7 meters per second. 18.8. I probably rounded something off incorrectly somewhere, but okay. Everybody follow me there? In most situations here, because there's a subtraction operation, I can't cancel it. The mass was part of this subtraction operation. Okay, if everything's being like multiplied together, then yes, like in a conservation of energy question, I can do it because every term is multiplied by it. In this case, not every term was multiplied by m, so I can't cancel it. All right, so this is one of those string breaking questions. So we know the maximum tension in the string is 186 newtons. Any more than that and it'll break. Okay, a 1.5 kilogram mass is being whirled around at the end of this string in a vertical circle with a radius of 1.90 meters. Okay, we're looking for the maximum speed the mass can be whirled at without breaking the string. It's basically the same calculation as 3 because the place the string would break, as we discussed yesterday, is the bottom of the circle, right? Because that's where the tension will be greatest, right? So we would have then this tensional force in, that's 186 newtons, gravity pulling out, which we'll have to calculate, okay? And then we'll have forces in minus forces out, right? And we solve for V. Okay, so it'll be, again, same calculation here, right? We're looking for V. So we got mv squared over r equals 186 minus mg. So I'm going to multiply both sides by r, divide both sides by m, square root, plug in my numbers and go. So it's the same as 3, just a different context. All right, any other ones? Okay, keep going.